Hi everyone, I'd like to start by sharing our three main customer requirements for the vertical axis wind turbine. Firstly, we wanted to use rapid prototyping as a means of producing our blades. Secondly, we want to create a desirable power coefficient curve. Last but not least, we were working within a $1,000 budget. Following some preliminary research, we decided to use the aerodynamic software QBlade to help us produce our coefficient of power curve. The results obtained from QBlade reinforced our choice to use the NACA series airfoil profile for our blade. The NACA series was developed by NASA and has been tried and true in the real world and will give us better results than we could hope to obtain from any of the other competing alternatives. As a secondary verification, the structural integrity was determined with SolidWorks and found to be sufficient. As you can see here, we have both a QBlade and a SolidWorks rendering of the blade design and blade arrangement that will produce the desired coefficient of power curve, and also a rendering of the final model itself. These are the blades that are being 3D printed. They require sanding afterwards before they're quite suitable for use. Shown here is a blade being sanded and inserted onto a dowel. Likewise, this is a strut being prepared for the strut cover. Lastly, this is the assembly of the strut clamp. So, shown here is the team setting up the required measurement devices in the tunnel so that we can collect data from the turbine while it is in operation. Last but not least, our custom jig employs the sine law to set a constant pitch angle for each blade independent of each other blade. Now, it's also worth mentioning here that the wind tunnel had some unscheduled downtime that interfered with our testing. Unfortunately, we weren't able to produce quite as many results as we would have liked. So shown here is a simulation of a simulation, showcasing some of the rules needed for good data collection and a functioning turbine. Thank you very much for watching.